Hello and welcome back. So far we have understood how a machine learning algorithm works with a simple linear regression algorithm example, and how exactly the linear regression algorithm is finding out those coefficients or pattern recognition, right? How exactly it is doing the pattern recognition we have understood a little bit. So let us try to look at the statistical outcome of the ordinary least squares algorithm, right? So here, when you use the model name summary, it actually shows you some statistics here. So we see R square score, adjusted R square score. This R square score should be close to 1 to say that model is working good, right? 0.908, this is called as metric, okay? So I said that the model is going to understand the pattern inside those 32 records we have passed, the salaries or the experiences and salaries, and going to derive an equation, and then we are going to pass the new person's salary experience into the equation and predict the salary, right? So before we use this equation or use the model to make predictions, we need to assess whether the model is working good or not. So we need to have metrics. There are different metrics like error, squared error, mean squared error, root mean squared error, R square score, adjusted R square score. We'll understand all these metrics in a next section, but in next video, right? But let us try to see at a high level, right? The R square score should be close to 1 to say that the model is working good. But here it is 0.9, that means it's close to 1. It has got 90% accuracy, I can say. The adjusted R square is a little more advanced than R square score. There are some disadvantages with R square score, like when you add new columns, even though column is important or not, the R square score will increase. But this adjusted R square score formula will try to nullify that additional features effect when they are not useful, right? So we'll see those formulas in a moment, right? But here the model is working good. It is giving 90% accuracy. That means it is 90% of the times it is predicting right, or when it is making a prediction, it is 90% of the actual value. And if the salary is 100, it may be predicting 90 or 110 or something like that. Okay. So here we have got some more statistics like F score and F statistic, that's called as ANOVA. And we'll see that in more inferential statistics part. And then if you look at this table, this is what I am interested in, because we have seen the confidence interval, standard error, p-value, t-test, all these things, right? So if you look at this, right, the coefficients are what? The intercept is 7882, that is theta 0, and the experience coefficient is 5171, that is theta 1. The standard error is 2885. What that means is this is kind of mean, right? If you found like 10 intercepts or maybe 32 intercepts for 32 rows, this is kind of a mean, and this is kind of standard deviation. And the t score is 2.732, just like g score, right? And then p value is 0.01, and the confidence interval, 95% confidence interval is 1989 and 13,800. It is 10 to the power 4, 1.38 into 10 to the power 4, right? So when you look at these numbers, right, what we can understand is, if you change the data in the data set and try to train the model, right, the coefficient may oscillate between, right, 95% confidence interval, right? They may 95% confident that the coefficient may oscillate between these two numbers when you change the data. That's what it is trying to explain. In the p-value, right, p-value is saying 0.01, right? If you take the significance level, 0.5, 0.05, right? This is less than that. That means you can reject the null hypothesis. What is the null hypothesis for linear regression? The feature and the target variable are independent is the linear regression's null hypothesis. So you can reject that. That means this intercept is important. Intercept is needed to make the prediction properly. Okay, the p-value here is actually trying to say that, okay, it is less than the significance level. So again, for the next experience, right, the coefficient is this much and the 95% confidence interval is this much. That means when you change the data, right, when some record gets added or some record gets deleted, the coefficient may lie in between these two numbers. We are 95% confident. I'll tell you why that is 95%. And the p-value is 0. That means definitely the experience feature is needed. Our experience feature is, the salary is definitely dependent on the experience feature. Right? The p-value actually gives you the features importance. Okay, there are approaches where you try to use p-value and see whether the feature is important or not. Backward and forward selection, right? So you try to play with the p-values and look at the p-values and try to select the important features. The feature importance is one more important concept where if you have 1,000 columns in your data set, you may have to figure out how which features are more important in those 1,000 features, right? So machine learning has got ways to find out the important features. With business knowledge, we can actually say that experience is definitely needed to predict salary. But if you have 1,000 features, right, hand picking each feature and trying to do business analysis and decide is going to be very difficult. So machine learning is giving you these kinds of tools. The p-value is the first level tool and we'll see more in coming classes. So here I am saying it is 95% confidence interval because if you look at the values, right, 0.25 and 0.975, right. So if you look at the normal distribution, here it is 0.025 and here it is, the point here is the 0.975. That means here we are leaving 0.025 and here also we are leaving 0.025. If you sum up these two, it's going to be 0.5. That means what? The 1 minus 0.05, sorry, 0.05. 1 minus 0.05 is 0.95. That is nothing but 95%. So 95% confidence interval is calculated, which is nothing but the mean, right? The coefficient 7882 minus 2 into the standard error, right? 2885 and the 7882 plus 2 into 2885, right? So these, when you calculate these two, right, you will get this number and this number. Okay, so let us try to do that. So or maybe not here. So here if you see this, at there also if you try to take the 2 into standard deviation or the standard error, right, and plus 2 into standard error, you will get these two numbers. So it is a 95% confidence interval. So this is the connectivity between the statistics and machine learning. In the coming video, let us try to understand error metrics for regression in a deeper way. Thank you.